Hi, everybody. Day 140. Hope you're having a decent week. Personally, having a pretty rough day today. Got some bad news today, which I'll share with you later when I can. Anyway, I hope you all are doing okay. I hope you're staying safe, not just in the virus sense, but personally. Um, some folks really struggle with not being around their friends um, and not having the space to be themselves, be around a support group of their peers. So I guess the one thing I'd ask from you today, in addition to doing your schoolwork, is make sure you're checking in on your friends. Ask them explicitly how they're doing. Right? Not just if they're doing okay, but just how are they doing, and giving folks space to be okay, but also to not be okay. Because sometimes when people aren't at school, they're kind of alone. So check in, make a phone call, make some voice to voice contact with a friend, maybe a friend that you haven't spoken with in a while, and see how they're doing. And check in with yourself. Sounds corny, but see how you're doing. Think about how you're feeling. If you need anything, feel free to reach out to your teachers, myself, others. We care about you guys. With that, science. So today's very light, just because I'm getting to this late. Uh, Goal for you: complete the knowledge inventory if you didn't already, and I'm going to post this video right here. So you should review it once you've completed the knowledge inventory. Also, there's a simulator called Waves on a String that we're going to use tomorrow, and I'm going to show that to you now. This link will take you here. Oh, oops. Okay. You won't get this message. I gave you guys the wrong link. So it'll take you here. You just click on the little play button there, and it'll open up the sim. And this is called Waves on a String. So most of you probably have something at home that you can use to make a wave. Things like a garden hose work great, but not everybody has a yard. You can use string. You can use a necklace that's not fragile. You can use an extension cord, but be careful because the end will whip. But a hose makes for a pretty good wave generator. Let's see. Here's mine. All right. So hopefully you can see that. And you can do this way, but you can also make waves that way. Right? And depending on what kind of surface you do that on, if it's a smooth floor, you can get some pretty impressive waves. So we use this sim because it makes great waves and it has lots of different options. You can do things like this. You can make a wave. You can move things in slow motion. It works pretty well. You can do a pulse. Push that button. You get one pulse. You can adjust the damping. All right, this is kind of like adjusting the friction. So there's lots of things that you can do with this tool. All right, see? You can also do things like change the end so that there's a loose end, which allows the end to do that, or you can make so there's no end, it just goes off into infinity. In that case, there's nothing to cause it to reflect back. So it does that. All right, and you can also set up an oscillation where it's just this periodic thing. All right, there's lots of things we can adjust down here. You can add in measuring devices, a zero line that you can move around. So just play around with this. All right? See what you can come up with. And again, you can adjust it to make it do lots of different things. Okay, let's go over the knowledge inventory. So if you haven't done this yet, please go do it now and then come back. If you did already do it, I made a couple mistakes. Just in my DNA. I got to make a mistake or two on every single one of these things, don't I? Which I've now fixed. So if you want to, I actually set it up so you can take it twice. So if you did it and you got some funny answers that you feel like were right, you can go back and change those so that the score that you have reflects your correct knowledge. I wouldn't consider that cheating, but we're going to go over these right now. So let's go here. Ah, yes. Okay. So, actually, most of these initial questions are. Ugh. Yes. Here. Okay, so first question. What is this going to look like after it reflects? With the fixed end, you can see it. Right there. So it flips. Right, the fixed end causes it to flip. If you had a loose end, it stays the same. Right. See here, the fixed end over here flips. The loose end allows it to stay on the same side. We'll go over why that is later. All right, let's go to, wait, where was it? Yeah. Next one. So that covers the first two. So loose end, it would stay the same, but it would flip around the reverse. So that'd be B. For the fixed end, it would go upside down and reversed. There's puberty again. Reversed order. So that'd be C. Sound. It's our third question. So this is going to, everything's going to come back in reverse order. So the part of the wave that hits the wall first is this part. And so that's going to be the first part moving away from the wall here. And then the part of the wave that hits the wall last is this trailing part here and here. And so those bounce off last here. Next, I asked you to think about whipping a rope. All right, so this would be like a horizontal movement. And so the next question is, if you advance one frame, so basically this little wave is moving, and that's backwards for your view. Okay, the wave is moving this way, and you go one frame. Where is this knot going to go? Well, since the wave is moving this way, this knot is going to move higher, right, as the wave goes by. Right, think of like watching something bobbing on the ocean. When a wave goes by, it pushes the thing, right? It pushes it up, and then the thing goes back down. If you floated in the ocean before, you've felt that, right? The wave brings you up, and then you go back down as the wave passes by. Okay, so if you did a new pulse, but it was quicker, it would be narrower, tighter, this way. If you tighten the rope, and you can try this with a little necklace, if you make it loose, the wave is wide. But the wave moves slowly, I should say. But if you tighten it, the wave moves fast. Did I skip one? I did skip one. All right, so for number 6, if you move your hand further, so a bigger whip, the pulse would be taller. Now, if we pull it tighter, it goes faster. And now we're making several waves. And so the question is, if you advance one frame, point A would be a little bit lower, right? Because these waves are moving to the right. They're propagating, that's what we call it, to the right. And so as the wave moves, this is basically like you're on the backside of a wave. It's moving away from you, and so you're moving down, all the way down here as it moves by. You're not going to move to the left, though. You're just going to go down, up, down, up, down. That's what would happen to you if you were out in the ocean. Excuse me, the waves don't really take you anywhere unless you happen to catch the curl. Otherwise, you just sit there and bob up and down. If you don't believe me, you can try this out in the bathtub or in the sink. You can just put some water in there, put something that floats, and then make a splash, and you'll see that that thing just basically moves up and down. It doesn't really move to the side. Okay, number 9. The pattern of waves will be what? Relative to the hand. So the pattern is going to move to the right. It's going to shift over to the right. And if the person starts over and moves their hand faster, the peaks will be the same distance apart, further, or closer. They'll be closer because there'll be less time in between when you do this, right? If you're going slow, then that gives the waves more time to move away from each other before you start the next one. But if you're going really fast, there's less time, and so they get more compressed. If you lowered the frequency, you will increase the length of each wave. Okay, that was the end of the ones on the pictures. Let's go to the rest of the questions. Which starts here with number 12. So, how does a wave, like light, transfer energy from one electromagnetic field to another? Displacement or distance moved from the equilibrium position. That's called the amplitude or the height. An equilibrium position would be the middle of the wave. And if I was going to show that to you on a picture, the equilibrium position would be right here at the 0 line. And so the amplitude of this wave, if I wanted to measure it, well, I'd put my 0 there, and when it goes by, I'd pause it, and I would just measure. All right, whatever that is. Looks like it's about a little bit less than 1 centimeter. Okay. Next one, number 14, the time for a particle on a medium to make one complete vibrational cycle. So time is a period. Right? Think of a period like a class. Right? It's the time for one class, one cycle of learning. So that's the reason the words are the same. So that's usually the easiest way for students to remember period is to think of periods in school. It's the time for one thing, one class to occur. In this case, it's for one wave. So one, most waves look like, oh, that's terrible. One, they kind of look like a sideways S. So one of those to go by. Next one, number 15, how often the particles of a medium vibrate when a wave passes through the medium. So how often would be frequency. How many times something happens. Number 16, the length of one complete wave cycle. Well, length is in the term, wavelength. This is the distance from peak to peak. So from one peak to the next peak, and there'd be a trough in between. Pitch, it's a synonym for frequency. You think of frequency of notes when playing music, and pitch, same thing, right? Bass is low frequency, treble, high frequency, lots of notes in between. Doppler effect for number 18. This is why when you hear a siren, it sounds higher as it's coming towards you, and then lower pitches as it's moving away from you. And the 3 primary colors, I screwed up on this one. I put red, blue, and green on here twice. Sorry. So it's just once. Should have been there once. And then the last is longest wavelength to shortest. So you probably heard of Roygbiv. If you haven't, ROYGBIV. It's a good acronym for memorizing the order of these colors. These are the colors that you see in the rainbow. And somebody a long time ago decided that that we had to include indigo in there. So we do. And that's it. That's all of those. Hopefully that makes sense. Thanks for watching, and I will see you tomorrow.